Welcome to the ultimate free fall. We are currently retreating from Earth at impossible speeds, leaving the Goldilocks zone where liquid water and life can exist. That bright flash is our sun, sitting 93 million miles, 150 million kilometers away. At this distance, you're seeing it as it was 8 minutes and 20 seconds ago, because even light has a speed limit. Watch how instantly our home vanishes. That's the inverse square law in action. And just like that, the sun is merely a dot. We've just crossed the heliopause, the boundary where solar wind gives way to interstellar space. For context, Voyager 1 is humanity's most distant object, currently over 15 billion miles, 24 billion kilometers out. Yet light travels that entire journey in just 22 hours. We are moving significantly faster than that, and the vertigo you're feeling, that's the realization that our entire solar system is shrinking into nothingness. Now look at the structure forming around us. That milky band isn't gas. It's the cumulative light of between 100 and 400 billion stars, all viewed edge-on from within the disk. We are seeing the forest for the trees now. This is the Milky Way, a structure spanning roughly 100,000 light-years in diameter, and we are finally exiting our local stellar neighborhood to see the galaxy's true architecture. See those dark patches obscuring the core? That's not empty space. That is the Great Rift. Massive clouds of molecular dust hovering around -400 degrees Fahrenheit, -240 degrees Celsius, just barely above absolute zero. These lanes are the grid of the galaxy, blocking visible light from the center. And deep inside those cold clouds is where new stars are being born right now. From this angle, you can see the spiral arms. But here's the physics twist. Those arms aren't solid structures rotating like a wheel. They are density waves. Think of them like a traffic jam on a highway. Stars move in and out of the arms, compressing gas and triggering formation. Our own sun orbits this center at a staggering 514,000 miles per hour, 827,000 kilometers per hour. Yet it still takes 230 million years to complete just one lap. We are now drifting into the galactic halo, a lonely region dominated by dark matter. In fact, 90% of the Milky Way's mass is invisible to us. The total mass here is estimated at 1.5 trillion solar masses, keeping this island of light together against the expansion of the universe. From out here, the galaxy looks less like a home and more like a solitary raft floating in a dark, infinite ocean. We've reached the pivot point. Suspended in the intergalactic void, the nearest major neighbor, Andromeda, is still 2.5 million light-years away. It's a tug-of-war out here, gravity pulling us back versus dark energy pushing everything apart. But we aren't going to Andromeda. We are about to surrender to the gravitational potential well of our own galaxy. Get ready. We are falling. We've initiated a free-fall trajectory straight for the heart of the Milky Way. Our target is Sagittarius A star, the supermassive black hole located 26,000 light-years from the edge. As we accelerate back towards that dense, bright core, we are converting all this gravitational potential energy into extreme kinetic velocity. Next stop, the event horizon. All right, mission start. We are crossing the intergalactic threshold and diving straight into the galactic plane of the Milky Way. Now, from the outside, our home looks like a solid disk, about 600 quadrillion miles, 100,000 light-years across. But look at that edge. It's razor thin, only about 6 quadrillion miles, 1,000 light-years, thick. Those dark, silhouetted bands aren't empty space. They're the interstellar medium, massive wall of dust blocking the starlight from the core. We're punching through the outer rim now, moving at superluminal speeds. It looks like a thick fog, but that's an illusion of our velocity. In reality, this space is a vacuum so perfect that a cubic mile of it has fewer atoms than a sugar cube of Earth's air. But at this speed, hitting a single microscopic silicate grain, less than 0.00004 inches wide, would release the energy of a nuclear bomb. Breaking through the dust, and suddenly, the view clears. Welcome to the galactic disk. This is where the action is. Between 100 and 400 billion stars, all locked in a flat orbital plane by the conservation of angular momentum. Out here in the suburbs, our neighbors are usually over 24 trillion miles, 4 light-years, away, giving us this deep, lonely perspective of the cosmos. Heads up, we're approaching a high-energy zone. See those bright blue points? That's a cluster of O-type stars. These are the rock stars of the universe, massive, volatile, and burning at surface temperatures over 50,000 degrees Fahrenheit, 27,700 Celsius. Compare that to our sun's 10,000 degrees. These giants are pumping out lethal amounts of UV radiation. We are weaving right through the nursery. This is an open cluster, a litter of stellar siblings born from the same gas cloud. They're packed tight, usually within a region just 10 to 30 light-years wide. Right now, they're a family, but over the next few billion years, the galaxy's tidal forces will drift them apart, scattering them into the void. Leaving the blue giants behind. Notice the color shift. The background is turning a dense yellow-white. We're entering the galactic bulge, the ancient downtown of the Milky Way. This spheroid is 58 quadrillion miles, 10,000 light-years wide, and populated by old redder stars that have long since exhausted their hydrogen fuel. The traffic here is about to get intense. Look at that density. We are deep in the core now. In our neighborhood, stars are light-years apart, but here, they're packed less than 600 billion miles from each other. If Earth were orbiting a star in this region, you wouldn't need a sun. The night sky alone would be 100,000 times brighter than a full moon. You could read a book at midnight just by starlight. And there it is, the gravitational anchor of our entire galaxy. That chaotic glow is swirling around Sagittarius A star. We're talking about 4.1 million solar masses crushed into a sphere with a radius of just 14 million miles. That's smaller than the orbit of Mercury. Everything we've just seen, all those billions of stars, are dancing to the tune of this monster. All right, team. We've finally arrived at the most dangerous coordinates in the Milky Way. That glowing maelstrom ahead, that's the accretion disk of Sagittarius A star. We're looking at 4.1 million solar masses crammed into a region roughly 15 million miles wide. That friction is heating gas and dust to millions of degrees, making it radiate violently before it feeds the beast. There it is, Sagittarius A star. We are 26,000 light-years from Earth, and look at the stars behind it. They're being smeared into rings. That is gravitational lensing in action. The gravity here is so immense, it literally bends the fabric of space-time, curving light rays around the hole like a cosmic magnifying glass. We are getting dangerously close to the shadow. That stark black circle is the event horizon, the point of no return. It has a radius of about 7.7 million miles, which would fit snugly inside Mercury's orbit. Once we cross that line, escape velocity exceeds the speed of light. Nothing, not even a radio signal, gets out. Hold on, we're diving into the inner disk. Matter here is whipping around at nearly 200 million miles per hour. That's 30% the speed of light. The physics get wild here. Due to time dilation, an observer on Earth would see us freeze in place forever. But for us, we are plummeting straight into the abyss. We just crossed the horizon. The visuals are breaking down into a tunnel of warped light. This is where you'd experience spaghettification. The gravitational pull at your feet is so much stronger than at your head that you'd be stretched vertically into a long, thin strand of atoms. Molecular bonds don't stand a chance. We are now inside the belly of the beast. Here, space and time literally swap roles. Moving forward in time now inevitably means moving forward in space, toward the singularity. There is no left or right that leads out. Every single future path ends at the center. The light is fading. We are approaching the singularity, a theoretical point of infinite density and zero volume. All remaining light is being blue-shifted to lethal energy levels. This fading glow represents the final loss of information as we disconnect from the universe entirely. And absolute darkness, zero photons. We have hit the singularity. Here, Einstein's general relativity predicts infinite curvature, but quantum mechanics suggests a state of matter we can't even comprehend yet. This is where our physics breaks down. Welcome to the unknown.